Welcome to the lesson on the relationship between zeros and coefficients of a polynomial. At the end of this lesson, you will be able to establish the relationship between the zeros and the coefficients of linear polynomials, quadratic polynomials, and cubic polynomials. Let's consider a linear polynomial 2x plus 5. Here x is the variable with 2 as its coefficient and 5 is the constant term. Now, let's find the zero of this polynomial. The zero of a polynomial is defined as any real number k, for which the value of the polynomial becomes 0. Let's assume that for x equal to alpha, the value of p of x becomes 0. Thus, p of alpha is equal to 0. This implies that 2 alpha plus 5 is equal to 0. On simplification, we get the value of alpha as minus 5 divided by 2. Here you observe that the numerator 5 is the constant term of the polynomial, and the denominator 2 is the coefficient of the variable x. Based on this observation, we can conclude that the zero of a linear polynomial is equal to the minus of the constant term divided by the coefficient of x. Now, let's consider the general form of the linear polynomial p of x is equal to ax plus b, where a is not equal to 0. Recall that a linear polynomial can have a maximum of one zero. Let's assume that alpha is the zero of the linear polynomial ax plus b. Hence, we can say that p of alpha is equal to 0. This implies that a multiplied by alpha plus b is equal to 0. On simplifying this expression, we get alpha is equal to minus b divided by a. Here b is the constant term and a is the coefficient of the variable x of the linear polynomial. This equation defines the relationship between the zero and the coefficient of the linear polynomial. Next, we'll discuss the relationship between the zeros of quadratic and cubic polynomials with its coefficients. Let's consider the general form of the quadratic polynomial. Recall that a quadratic polynomial can have a maximum of two zeros. Let's assume that the zeros of the polynomial p of x are alpha and beta. Here we will apply the factor theorem to determine the factors of p of x. Recall that the factor theorem states that if a is a zero of a polynomial p of x, then x minus a is a factor of p of x. In case of a quadratic polynomial, if alpha and beta are zeros of the polynomial p of x, then the factors of p of x are x minus alpha and x minus beta. Thus, the quadratic polynomial is equal to k multiplied by x minus alpha multiplied by x minus beta, where k is a constant not equal to 0. Let's multiply the factors on the right-hand side of the equation. The equation obtained is as shown. Now, let's compare the coefficients on both the sides of the equation. A is equal to k. This is by comparing the coefficient of x square. Let this be equation 1. B is equal to minus k multiplied by alpha plus beta. This is by comparing the coefficient of x. Let this be equation 2. And c is equal to k multiplied by alpha multiplied by beta. Let this be equation 3. Now, let us use the equation 1 and equation 2 to get this relation. This equation indicates that the sum of the zeros is equal to minus b divided by a. Here b is the coefficient of x and a is the coefficient of x squared. Therefore, this equation establishes the relationship between the sum of zeros and coefficients of the quadratic polynomial. On using equation 1 and equation 3, we get the product of zeros, which is equal to c divided by a. Here c is the constant term and a is the coefficient of x squared. Therefore, this equation defines the relationship between the product of zeros and the coefficients of a quadratic polynomial. Next, let's consider the general form of the cubic polynomial. Let's assume the zeros of a cubic polynomial p of x are alpha, beta, and gamma. Based on the factor theorem, if alpha, beta, and gamma are zeros of p of x, then the factors of p of x are x minus alpha, x minus beta, and x minus gamma. As we have seen in the quadratic polynomial, the cubic polynomial is equal to the product of its factors. Let's simplify and rearrange the right-hand side of the equation. Now, we'll compare the coefficients of x, x squared, x cubed, and the constant term. A is equal to k. Let this be equation 1. B is equal to minus k into the sum of zeros, alpha, beta, and gamma. Let this be equation 2. C is equal to k into the sum of the product of zeros taken 2 at a time. Let this be equation 3. D is equal to minus k into the product of the zeros. Let this be equation 4. Using equation 1 and 2, we get the sum of zeros is equal to minus b divided by a. Here b is the coefficient of x squared and a is the coefficient of x cubed. Therefore, this equation defines the relationship between the sum of zeros and the coefficients of the cubic polynomial. Next, by using equation 1 and 3, we get the sum of the product of zeros taken 2 at a time is equal to c divided by a. Here c is the coefficient of x and a is the coefficient of x cubed. Therefore, this equation defines the relationship between the sum of the product of zeros taken 2 at a time and the coefficients of the cubic polynomial. Similarly, using equation 1 and 4, the product of zeros is equal to minus d divided by a. Here d is the constant term and a is the coefficient of x cubed. Therefore, this equation establishes the relationship between the product of zeros and the coefficients of the cubic polynomial. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. The zero of a linear polynomial is equal to the minus of its constant term divided by the coefficient of x. If alpha and beta are the two zeros of a quadratic polynomial, then the sum of the zeros of a quadratic polynomial is equal to the minus of the coefficient of x divided by the coefficient of x squared. And the product of the zeros of a quadratic polynomial is equal to the constant term divided by the coefficient of x squared. If alpha, beta and gamma are the three zeros of a cubic polynomial, then the sum of the zeros of a cubic polynomial is equal to the minus of the coefficient of x squared divided by the coefficient of x cubed. The sum of the product of zeros taken two at a time of a cubic polynomial is equal to the coefficient of x divided by the coefficient of x cubed. And the product of the zeros of a cubic polynomial is equal to the minus of a constant term divided by the coefficient of x cubed. Hope you enjoyed this learning experience.